Okay, so we'll be looking at another topic, partial derivatives of implicit functions. I hope you remember implicit functions from your this in elementary calculus. That's NCH 106. When I think of implicit function, you just remember an equation that has there's a mix with different variables, like let's say 6x squared plus 2xy plus 3y squared equal to 0. You're giving something like this. If you want to get and they ask you to find the y over dx, normally you differentiate through with respect to x. Then like something like this now, if you want to differentiate, you're going to use product rule between them. So it's going to be 2 brackets v du dx plus u. The ratio of y with respect to the x is going to be dy over dx. So this is what you do for this one too. It's going to be 6y dy over dx. Then you make the x dy over dx subject to formula, then move the other ones. So that's what we'll also be doing here. Then when we get down into it, you see what I'm talking about. If you don't remember the last one you did. So now we say let f be a function of x comma y. X is a function of t and y is a function of t. You remember. Now the f over dt is equal to partial f over partial x times dx over dt plus partial f over partial y times dy over dt. Now they said if x is equal to t, from this equation, if x is equal to t, then we're going to have the f over dx is equal to partial f over partial x times the x over dx plus partial f over partial y times the y over dx. Now the x over dx will cancel out, so the f over dx is equal to partial f over partial x plus partial f over partial y times the y over dx, and we call this equation 1. Now if f is equal to 0 is an implicit relation between x and y, where y is a differentiable function of x, then from 1 the f over dx is equal to 0. So what I'm saying is, let's say implicit function is kind of like I told you, it's an equation mixed with different variables. So we have this now. We can call this f. So the functions here, f is a function of x and y. So we can say fx comma y is equal to 0. If you want to differentiate this stuff with respect to x, we said y, where y is differentiable, is a differentiable function of x. So we want to differentiate this stuff with respect to x now. The f over dx, right? I guess the f over dx is equal to 0. Or you could say the f over dx is equal to d0 over dx. The range of 0 with respect to x is 0. That was like the explanation I got. I will not lie. That was kind of like the how I got it. So the f over dx is equal to 0. Since it implies that this now is going to be equal to 0. This is equal to 0. So make the y over dx subject to formula. But I guess this explanation is kind of correct. If you call this, we call this whole equation f and equate it to 0. Yes, let's remove x and y. Let's just call this whole equation f and equate it to 0. Differentiate both sides with respect to x. The f over dx is equal to 0. That is an easy way that I understood it. So if the f over dx is 0, then it means the right hand side is also equal to 0. Make this the subject of formula. Partial f over partial x is going to go over to the other side, so it's going to become minus partial f over partial x. Divide both sides by partial f over partial y. So your dy over dx is equals to partial f over partial x all over partial f over partial minus partial f over partial x all over partial f over partial y, provided partial f over partial y is not equal to 0. Now if you're given an implicit equation, let's say it contains three functions. Now let's say where w is an implicit function of x and y, then the w over the x is equal to partial w over partial x. um how do you make this work? How do you remember what I told you in the first one? When you want to find the y over the x, you make the y over the x with the formula. It's the same thing here. But this one now, you're given three. Recall we are doing calculus of several variables, so now you're given an equation with three variables or unknown, x, y, and z. I mean x, y, and w. But now w is the differentiable this thing, the differentiable function of x and y. W in this one, in this relationship, we had that y is the differentiable function of x. But here now, w, okay, we called it implicit function of x and y, or I would say differentiable function of x and y. Then partial w over, so since w is an implicit function of x and y, recall once it's two variables, you're going to differentiate partially. We have to differentiate partially with respect to x and partially with respect to y. So now partial w over partial x is equal to minus partial f over partial x over partial f over partial w, and then partial w over partial y is equal to minus partial f over partial y all over partial f over partial w, provided partial f over partial w is not equal to 0. Alright, so look at this question. If sine square x minus 5 sine x cos y plus tan y is equal to 3, find the y over the x. This one that is kind of like in a box is the first way of solving implicit functions. That's from 106. Now you're giving this equation, you take everything to the left hand side, equate it to 0. You will differentiate through with respect to x, like I said in just a while ago. Recall this is sine x raised to power 2. So when you're differentiating, it's going to be 2 sine x times differentiation of this is cos x. So you have 2 sine x cos x. We have 2 sine x cos x minus, I told you you're going to, when you're differentiating now, you're going to use products rule. Your math stuff, you're going to use products here. So it's going to be v times du dx, differentiation of sine x with respect to x is cos x, plus u, which is sine x, times dv dx. This is going to be minus cos y. I'm sorry, minus sine. Division of cos is negative sine, so you have minus sine y dy dx to show that you differentiated this with respect to x. So you have minus sine y dy dx plus division of tan y with respect to x is going to give you sec square y dy dx, sec square y dy dx. Then you have minus 0 equal to 0. So let's open the bracket. You're going to have 2 sine x cos x minus 5. So I just did cos x cos y. You have a minus here. Minus and minus will give you plus. So you have plus 5 sine x sine y dy dx plus sec square y dy dx equal to 0. Collect like terms, the ones with dy dx, move the other ones over. So I picked out this one and this one, factorize them, factorize out dy dx, and then move this one to the other side. It's going to become positive while this one is going to become negative. Divide both sides by this so that the y dx will stand alone. The y dx is equal to this divided by this. That's by the normal method. Now by partial derivative method, let's make use of those formulas we learned. You're given the equation, you're given this equation. We call the equation f. We call the equation f. Now partial f over partial x is 2 sine x cos x minus 5 cos x cos y. You see how? You know how we got this one. This one now is just you're going to differentiate only the sine x here, while these two remain as a constant. So differentiation of sine x is cos x. Differentiation of tan y with respect to x, there's no x here, so this is 0, this is also 0. Now differentiation of f again with respect to y is this what we're looking at. Negative sine y. So you have minus 5 sine x times negative sine y. These two are constants, so this is what we are differentiating. Negative sine y plus differentiation of tan y is sec square y. We will multiply the minus sign, you're going to get a positive 5. So you have 5 sine x sine y plus sec square y. Recall when you differentiate 3 with respect to y is 0. So that's that. Now dy dx, the formula dy dx is equal to minus partial f over partial x all over partial f over partial y. We have our partial f, we have our partial y. It's quite simple. I think it's even shorter. What you do, you just put this now, partial f over partial x, you put it recorded as a minus, so you have to put your minus sign in front, divided by partial f over partial y. Now open the bracket with the minus sign. When dy over dx is equal to minus times minus is positive, so I prefer putting the positive in front. Then this is going to be negative all over this, and if we compare the two answers, that they are the same thing, so either of them goes, but I guess partial is a bit easier since it's just a formula. You just know what to look for, and you put it in the formula and you've gotten your answer straight away. The next question is, given that z raised to power 3 plus xy minus y squared z is equal to 6, obtain the expression for partial y over partial x and partial z over partial x, and find their values at the point x. Alright, so this is what I was talking about. So you have an implicit equation with three variables. This one is made up of x, y, and z. So here now, yeah, they're saying y is a differentiable function of x, and here they say z is a differentiable function of x. It could also be that x is a differentiable function of y, and then maybe z is a differentiable function of x. So you could find, like, there are different things they could ask you to find, but it's just depending on how well you know the formula. So you're looking at this now. You're looking at this. How should the formula be? The formula will just be minus the f over the x, the one under first, all over the one you're differentiating with, or the one that's being differentiated. For this one is going to be minus the f over the x all over the f over the z. That's it. That's it. So let's go. They say you should find partial y over partial x and partial z over partial x, and find their values at the point 0, 1, 2. Okay, so solution, you write down your equation, take everything to the left hand side. Now we call the equation f. The partial y over partial x is equal to minus partial f over partial x all over partial f over partial y. Partial f over partial x, let's look at it. This is f, so we are differentiating this with respect to x. The only x we have here is this, so differentiation of this is going to give you y. This is 0, this is 0, this is 0, so that's y. Partial f over partial y, we have y here, we have y here, so this is 0, this is 0. Differentiation of this with respect to y is x. Differentiation of this with respect to y is minus 2yz. So we have x minus 2yz. So partial y over partial x is equal to minus the f over the x is y all over x minus 2yz. Now they said, and find their values at the points 0, 1, 2. At 0, 1, 2. So these partial y over partial x, partial y over partial x, at 0, 1, 2. That's how we write it. Is equal to your y is 1, so you have minus 1 all over your x is 0, 0 minus your z is 2. Okay, sorry, 0 minus 2 brackets y is 1, z is 2 is equal to minus 1 over minus 4 equals to 1 over 4. And then for partial z over partial x, the formula is minus partial f over partial x all over partial f over partial z. The f over dx is equals to y. The f over dz is equal to 3z square minus y square. Let's look at it together and know how we got the answer. The f over the x, the f over the x, okay, is here. Differentiate this is y, this is 0, this is 0, this is 0. The f over the z, this z we have, okay, we have z and we have z here. So this 0, this 0. So differentiation of this with respect to z is 3z square. Differentiation of this is minus y square. So that's how we got this answer, y and 3z square minus y square. Alright, so the z over partial x is equals to minus partial f over partial x, which is y, so minus y all over 3z square minus y square. So now partial z over partial x at 0, 1, and 2 is equals to minus 1 over, putting the values. Yes, go through it, and this will be your answer, minus 1 over 11. And the final question I have here, if f is equals to this, x is over 3 plus y squared plus 2xy minus 4y, find dy over dx. Yes, that's a full dy over dx. Okay, yes, yes, yes. You know y is dy over dx. We are given two functions, so here y is just a differentiable function of x, so it's dy over dx at 1 comma 2 by method of partial derivative. Okay, yes, 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 yes. Okay, 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 okay. So f is equal to this. The formula dy over dx is equal to minus partial f over partial x all over partial f over partial y. Partial f over partial x, let's do it together. Partial f over partial x is this and this, so this 0, this 0, this 3x squared plus 2y. Yes, partial f over partial y is this and this, so this 0, this 2y, this 2x, and this minus 4. That's it here. So dy over dx is minus partial f over partial x, so minus everything here all over this. Opening with your negative sign, this is what you get at the point 1 comma 2. Let's say at the point 1 comma 2, at the point 1 comma 2 you substitute, and this is the final answer. Alright, so that's it. Be sure to solve along and cross check in case I made a mistake.